Hey guys, in this lesson we will talk about the basics of exponential functions. Exponential functions are the functions that are written in the form of y is equal to b to the power x. So here you will notice that the variable x or the independent variable is written as a power. Dependent variable is always outside on the other side of the equal to sign, and b is the base of this power. Exponential functions can be of two types. One is where b is greater than 1. The other is where b lies in between 0 and 1. We'll take up both the examples by drawing graphs and writing the characteristics so that we understand how is b greater than 1 different from b is in between 0 and 1. So let's say we take the first example where b is greater than 1. Therefore, our equation is going to be y is equal to 2 to the power x. So here b value is greater than 1. Now to understand this exponential function, the best way is to turn it into a graph. Before doing that, we'll turn this into a table, and then we'll use the table to turn or to make the graph. So here goes the x value, here goes the y value. Now the simplest x values for an exponential function we can always use is -1, 0 and 1. If we put y is equal to 2 to the power of -1, it gives us 1 over 2. So y value is 1 over 2. If you put y is equal to 2 to the power 0, any number raised to the power 0 is 1. If you put y is equal to 2 to the power 1, the value of y is going to be 2. So we got this as table of values. Now let's make a coordinate axis and turn this into a graph. X values are -1, 0, 1. Y values are half, 1 and 2. So let's say 1 is here and 2 is here. Half is going to be somewhat here. When x is -1, y is half. So this is half. The point is here. Next is when x is 0, y is 1. That is here. Next is when x is 1, y is 2. Now when we connect this into a graph, when we connect these dots, we get this kind of a graph. If we extend this table of values, then we would keep on going up, up, up. And we would always notice that if we take values that are lower than -1 on the x-axis, the graph is always going to yield a positive y value. So that means the graph always goes above the x-axis. That's why in this case, x-axis is called a asymptote. And since this is a horizontal line, so this is called horizontal asymptote. Horizontal asymptote or the horizontal line is always represented as y equal to, and it's on the x-axis, or the y value for this horizontal asymptote is 0. So we would write down that horizontal asymptote is 0. There is no vertical asymptote on exponential function, but there is always a horizontal asymptote on exponential function. In this particular case, the horizontal asymptote is y equal to 0. Now when we look at this graph where b is greater than 1 or y is equal to 2 to the power of x, we can write on some characteristics for this graph. First characteristic is we see that this graph is increasing. When we go from left to right, this graph always goes up. So it will keep on going up, it will never come down. So that's why this is called a growth graph, or we can call it an increasing graph. The increasing interval is the value on the x-axis because it's always going up from -infinity to +infinity. So it's always directed upwards. That's why the interval of increase is -infinity to +infinity. And we put this in a bracket like this. Horizontal asymptote is also part of the characteristic. So we can write on there is a horizontal asymptote of y equal to 0 in this graph. We can clearly see that this graph crosses the y-axis at y equal to 1. So this is called the y-intercept. There is no x-intercept because x-axis is the horizontal asymptote, so it will never touch it. Asymptote is just an imaginary line where the graph is never going to touch or cross, but it can go close to the line. Next, we would write on the domain and range for this function. Domain is, we can clearly see xer because x value lies from -infinity to +infinity. Whereas range is going to be yer, where y value is always going to be greater than 0. And why is it greater than 0? Is because it will never go below the x-axis, as the asymptote is never going to let the graph cross itself. So these are the characteristics that we have drawn out of this graph. Let's take another example where y is equal to 3 to the power x. So here also b value is greater than 1. When we turn this into table of values, we can always use x as -1, 0 and 1. So the y value would be equal to, in this case, 3 to the power of -1, which is equal to 1 over 3. So we get 1 over 3 here. 3 to the power of 0 is 1. We get a 1 here. 3 to the power of 1 is 3. When we use these values and turn it into a graph, we get negative 1 here. We have negative 1, 0 and 1. On the x-axis, on y-axis, we have 1 over 3, 1 and 3. So let's say this is 1, this is 2, this is 3. 1 by 3 is going to be somewhat here. Now when we turn this into a graph, when x is negative 1, y is 1 by 3. So it's going to be here. X is 0, y is 1. X is 1, y is 3. And we notice that this graph, or the green graph, is kind of similar to the yellow graph because both of these graphs have b value greater than 1. Let's write on the characteristics. We would see it will never cross the x-axis. Therefore, here we would notice a horizontal asymptote. So we have a horizontal asymptote at y equal to 0. Next is this graph is also increasing graph, and it is increasing from negative infinity to positive infinity. Y-intercept is 1. There is no x-intercept, and domain is xer. Range is yer, where y is greater than 0. So horizontal asymptote is 0, increasing interval, y-intercept is 1, domain and range. When we look at the yellow characteristics, this also has the same characteristics, increasing graph. Horizontal asymptote is y0, y-intercept is y equal to 1, domain is xer, range is yer, where y is greater than 0. So all these characteristics are same when the b value is greater than 1. Let's take an example where b value is in between 0 and 1. That means b is a proper fraction. So the example we can take is y is equal to 1 by 2 to the power of x, or it can be written as decimal as well, 0.5 to the power of x. Now when we turn this into a graph, x values are always meant to be taken the same. You can take any other x values, but these are the simplest x values that will make life easier. So negative 1, 0 and 1. Now here y value is half to the power x. So you'd put half to the power of negative 1, and negative 1 power means the base flips, so we would get a 2. Next is half to the power of 0. Any number raised to the power of 0 is 1. Next is half to the power of 1, which is half. Now let's use these values to turn it into a graph. We have x is negative 1, 0 and 1. Let's say this is 1, this is 2. Half will be here. Now when x is negative 1, y is 2. It's here. X is 0, y is 1. That's here. X is 1, y is half. That's here. When we connect the dots, the graph looks like this. The graph is not going to cross x-axis, so there is a horizontal asymptote at, again, y equal to 0. So let's write down the characteristics looking at the graph. We see this graph starts on top and keeps going down, and this will keep on going down. However, it will not cross the horizontal asymptote, but it can go close to the horizontal asymptote. Therefore, this graph is a decreasing graph, or this is also called decay graph. And entirely from negative infinity to positive infinity, it is decreasing. Second is we have a y-intercept at y equal to 1. We have a horizontal asymptote at y equal to 0. Fourth is domain is xer and range is yer, where y is still greater than 0. So we notice that domain and range for all the functions are similar. Y-intercept is similar, horizontal asymptote is similar. The only difference between the graph where b is greater than 1 and the b is in between 0 and 1 is when b is greater than 1, there is an increasing graph, whereas when b is in between 0 and 1, the graph is a decreasing graph. So we can finally conclude here that b greater than 1 is a growth graph and b in between 0 and 1 is a decay graph. All of the characteristics are similar no matter what's the value of b is. So if we're asked to turn exponential functions into graphs, we know how to do that by turning it into a table of values and then into a graph. And then we know how to write down the characteristics of exponential function graphs where b is greater than 1 as well as when b is in between 0 and 1.